solve activity 2.6. In this activity, you have been given a block of data. You have been given 9 bytes. You have been asked to tell if any error has occurred during data transmission. You have to find out the location of error. As you can see that you have been given 9 bytes and you have been given 8 bits. The last byte is the parity byte. This parity byte is formed to set an odd parity of all columns. Like if this is one column, if the parity is not odd of these 9 bits, then the 10th bit will be set to 1. If the parity of this one whole column is not odd, then this 0 will make if the parity of this column is odd, then 0 will be written in the parity byte row, and so on. Now we are going to calculate the error in this block of data at the receiver's end. Let's start checking the parity of bytes. This is first byte, and let me count. Its parity 1, 2, 3. 3 is an odd number and we required an odd parity, so the parity of first byte is correct. There is no error in first byte. Now let's check the second byte. This is the second byte. Let's check the number of ones. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7, which is an odd number. So as we required an odd parity, so the second byte is also correct. There is no mistake in it. 3. It has 3 ones, which is an odd number. As you know that we required an odd parity, so this third byte is also correct. Now let's check the fourth byte. This is the fourth byte, and let's check the number of ones. 1, 2, 3, 4, and you can see that 4 is an even number, so it means that there is an error in this fourth byte. And as you can see in the question that you have been told that one of the bits has been changed. So there was error only at one location. We have found out the error in the horizontal row. Now we are going to check the vertical columns. We will remember this horizontal row, and now we are going to check the vertical columns. Let us check the vertical columns. Let us check the first parity bit column. Why is it called parity bit? Because the sender had counted the number of bits in the rest of the 7 bits, and if it was odd, the sender had added a 0 in the beginning over here. So this first column was set by the sender at the time of formation of data. Now let's check the parity of the first column. This is 1, 2, 3, 4, and 5. You can see that there are 5 ones and 5 is an odd parity, so there is no mistake in the first column. Now let's check the second column. 5. You can see 5 is an odd number, so there is no mistake in the second column also. Now let's check the parity of the third column. 7. 7 is an odd number, so there is no error in this third column. Now let's check the fourth column. 5 is an odd number, so there is no mistake in the fourth column also. Now let's check the fifth column. 5. 5 is an odd number, so there is no mistake in the fifth column also. Now let's check the sixth column. This is the sixth column, and let's count the number of ones in this column. 1, 2, 3, and 4. As you can see that 4 is an even number and we required an odd parity, so the mistake is in bit 6. And to find out the point of error in any location, we see the bit at the intersection. So the bit at the intersection is 0. So you can say that there was an error in the 4th byte and 6th bit, and 6th bit, and the 0 at their intersection should be replaced with a 1. Now let's start solving question number 2, in which an even parity was required. So let's check the parity of second part. We will check all the parity of all the bytes first. And 2 is an even number, so there is no mistake in the first byte. 4, which is an even number, so there is no mistake in the second byte. Now let's check the third byte. 4, which is an even number, so as we required an even parity, so things are going fine. Now let's check the fourth byte. 6 is an even number, so there is no mistake in the fourth byte. Now let's check the fifth byte. 2 is an even number, so there is no mistake in the fifth byte also. Now let's check the sixth byte. 6 is also an even number, so there is no mistake in the sixth byte also. Now let's check the seventh byte. 3. You can see that 3 is an odd number, and we wanted an even parity, so there is a mistake in byte 8. Because the error is at one location, so we have found that one byte. Now let's start checking the columns. And 4 is an even number, and we wanted an even parity, so there is no mistake in the parity bit column. Let's check the second column. And 4, which is an even number, so which is an even number, so this column is also perfect. Now let's check column number 3 and 6. 6 is an even number, so there is no mistake in column number 3 also. Now let's check column number 4, which is bit 4, and 6. As you can see, 6 is an even number, so there is no mistake in bit 4, column 4. Now let's check bit 5 or column 5 and 4. 4 is an even number, so and as you know that an even parity was required, so bit 5 also does not have any mistake. Now let's check bit 6 or column 6. 6 is an even number, so there is no mistake in bit 6 also. Now let's check bit 7. 3 is an odd number, so there is an error in bit 7. Now let's highlight bit 7 and byte 8. You can see that there was a mistake in bits at the intersection of bit 7 and byte 8. So you can say that the 0 bit at the intersection of bit 7 and byte 8 should be replaced with 1. So this was activity 2.6. We will do activity 2.7 next time. Thank you.